Every exponential question that we're going to get is going to give you an equation. So same thing here. If you had this question, you would have the following, you can steal it from the question beside us, you'd have the following equation. Where h is the height above sea level and p is pressure. And I don't know if any of you have ever had altitude sickness before. So it's happened to me a couple of times. When I lived in South America, we would travel to different places, and some of them are very high in the mountains. So one time I was traveling in a bus, I was asleep at night, the bus was just going straight up in the mountain, and in the middle of the night, I woke up, I was sweating, and I felt like I couldn't breathe. Altitude sickness comes from the fact that you go higher up, air level is thinner, your body's not used to breathing in and not getting as much oxygen as it's used to, so it goes into sort of a state of sickness, feels like a fever. The airport in La Paz in Bolivia is the highest international airport in the world, and it has an altitude sickness bay because people land, get off the plane, and aren't used to the altitude and get sick right away. The airport in La Paz, just to put it into perspective, the airport in La Paz is roughly at 4,000 meters above sea level. To put that into perspective, there are a couple, maybe two, maybe three mountain peaks in Canada that are higher than that. But most of Canada is well below where this airport is. Now, it's not like when you fly into La Paz, there's just like an airport runway on a, like you imagine a mountain peak, you think of a sharp, pointy thing. No, the mountains in Bolivia are very flat at the top. So just sort of land on what looks like a plane like Manitoba, you just happen to be super, super high above the ground. So in this question, it's saying the cabin pressure in an airplane is less than 70 kilopascals. Passengers can suffer from altitude sickness. To the nearest kilometer, at what altitude is it? 70 kilopascals. So we plug in 70 here. And again, 0.88 is not on your powers chart. So the only thing we can do to solve this at this moment is go to Desmos or our graphing calculator and type 1 into y1 and 1 into y2. So I'm going to go to Desmos. I'm going to type in 70 here. And once again, I'm going to need to see what my window looks like. So I'm going to go to my tool. Because y equals 70 is a straight line, I'm going to put my maximum at 100 and my minimum at -5. And sure enough, with doing that, I can see it can click on one, 2.891. Which puts it into perspective. If you can get altitude sickness at 2.891 kilometers, which is 2,891 meters, and the airport in Bolivia is at 4,000 meters, it's not surprising that you get a lot of people with altitude sickness when they come off that plane. It is fascinating to fly into that airport because the change in pressure, you don't realize what it does to things. Like I wear contacts, and my contacts lens bottle has a little lid so it doesn't spill. It was just about like, the pressure on the inside was pushing the bottle out and wanted to explode. When I opened my toothpaste, the toothpaste came out automatically. Pens, the inks just starts to run out because the pressure, even inside the pen, would push it out. The same thing when I flew back from La Paz down to Santa Cruz, another city, which is only 250 meters above sea level. All of my things that were closed were like shrinked. Like your toothpaste was like sucked in and tight. And my contact lens bottle was like pushed in. It was hard to open because of the pressure change. So it was really interesting to see that pressure change as you go from one place to another. You gotta be careful with the pens because the ink just like literally started to run out of my pens. All right, questions for practice on this one?
Number 14.